Hi everyone. Thanks for looking at the video tonight, and we're to a point where we have to speak about some new concepts. And what we'll be talking about tonight is evaporation and vapor pressure. We have to ask ourselves some guiding questions. What is evaporation, and why do different substances have different vapor pressures? To start us off, let's look at something you already know. I'm sure all of you have boiled something on the stove at one point or another. So we have to take notice to what's going on when something's boiling. You see bubbles coming up through the liquid. You see steam rising out of the container. And over time, you'd also notice that the water level goes down. There's nothing that's mysterious about this. So what did you see? You saw bubbles coming up through the liquid. You saw steam rising out of the container, and over time you'd notice that the water level goes down. That's just to reiterate. Why is all of this happening? Because you're adding energy to the liquid, it's becoming a gas, and it's escaping the liquid. So the water level decreases because the water is leaving the container in the form of steam. And another scenario that we should consider is, what if I took a regular cup of water and put it out at room temperature, but left it out for a couple days? In this situation, you would also see the water level coming down. So were you boiling this? Did it spontaneously boil? What occurred here? So again, the second scenario is a cup of water is left out after a couple of days. What do you see happening? You see the water level go down. So because boiling didn't occur, we call this evaporation. But what exactly is evaporation? We didn't add any heat this time. Well, we didn't see any steam coming out of the water. Where did the water go? And what is evaporation? Definition of evaporation will be, evaporation is the process of a liquid becoming a gas without boiling. Let's take a minute and examine the molecules in that cup of water to do a closer investigation. Here's the cup of water, and here are all the molecules. So we have all these molecules of water right here, and what will happen every now and then is one of these molecules will be able to escape the liquid. So being that we said that some of these molecules can escape the liquid, and once they become a gas, they actually leave the container. So after a certain amount of time, the water level of the water, the surface of the water will go down because enough of the molecules have escaped and have left the water, and we call this evaporation. So we definitely have to ask ourselves, how can this happen? How come some of the molecules can leave the cup of water? And can this happen at any given temperature? And I said at any given temperature because, remember, we didn't boil this. We continue to say that water boils at 100 degrees Celsius, but we looked at a cup of water and we left it out over 2 days. So it was evaporation. So at any given temperature, the water molecules can leave. So again, I asked the question, how can this happen at any temperature that the water molecules can leave? Now let's go back and think about what we said about what temperature was and is. We have to remember that temperature represents the average kinetic energy. So some of the molecules are moving very fast and some of the molecules are moving very slow. So this ends up being a range of temperatures. Remember the model that we used? We looked at a couple of models when we talked about kinetic energy, but there was the picture of the marbles, and it was a box shape, and there were all different marbles, and they were banging into the walls, and some of the marbles were like really going quickly by, and some were being bumped into and moving slowly. But yet we said that entire model was representing a temperature because it was the average of all those moving marbles that represented the molecules moving. So kinetic energy is an average of all the moving molecules. Let's take a minute to look at this energy diagram. So the energy diagram relates the number of molecules to the kinetic energy of the sample. And we just said that kinetic energy is an average. So this is showing you the distribution of all the different kinetic energies. And it's all of the molecules. And we said this, that the evaporation did not take place at the boiling point. So that means over here, these molecules that have a higher amount of kinetic energy have the ability to break away from that liquid. So to say it another way, we have some molecules over here that have high kinetic energy. Realize that right here is where the average is, so that's what the temperature of the liquid is. But over here, there are some of them with very high energies, and if there's a chance that they make it to the surface and they have this high energy, then they are able to break free out of the liquid and become a gas. So we're to the point where we should understand that there's a minimum amount of energy needed to escape the liquid. And it happens that correct minimum number of energy is with these few molecules over here that happen to have high kinetic energy for this particular sample of molecules. So the minimum amount of energy needed to escape the liquid, this small number of molecules have just enough energy to cause what we call evaporation. Now, understand that when some of these molecules leave, it ends up lowering the average kinetic energy. So interestingly enough, evaporation is a cooling process, which I think we already know. So now when we go back and we look more closely at this liquid, and remember there are all these molecules near the surface, and some of them have that high energy, and they can move all over the place. And some of the gas molecules are actually escaping from the liquid. And when they escape, they're moving quickly and they're colliding with things. And these collisions cause pressure. And just like any other gas that causes a pressure, we call the actual vapor created above a liquid from evaporation, we call this the vapor pressure. So it is important to point out that there are molecules that are colliding and as a result escaping altogether, but then there are also molecules that are colliding and escaping and hovering above the water, and that is what we call the vapor pressure. But also understand some of the molecules are returning and being recaptured by the liquid. But when we find a balance between the amount of molecules that are pushing up and out of this liquid and existing in the gaseous form, combined with the amount that are going back into the liquid, that's what we define as the vapor pressure. Okay, everyone, so to finish up for tonight, we talked about what evaporation is, we established what vapor pressure is, and when we get together in class, we're going to talk about vapor pressure, and we're going to talk about how vapor pressure is influenced by both temperature and intermolecular forces. In addition, we'll do a couple of demos. So I look forward to seeing everyone on Monday, and have a great weekend. I almost forgot, it's Halloween. Please be safe and have fun.